All right, guys, welcome to the video. We're going to be covering the key for the practice test for Unit 1. So please make sure you're paying attention, and if you have any questions, that you are prepared with them whenever we see each other again. All right, jumping right in. Numbers 1 and 2 have to do with points, lines, and planes. Before we get too far ahead, your answers might vary from mine here because there's lots of different options, especially when our answers are points, at least for problem A here. So I chose D, A, X, and W because non-coplanar means that they're not allowed to be on the same plane, which is that flat surface extending in all directions. So D, A, and X are all coplanar. They are on plane K. So D, A, X are all on this flat plane, but W is shooting out above it. So that's really what makes it non-coplanar there. Another name for line Q, well, Q is here, so I chose to name it line DF. Remember, you could use DE, EF. You can go in the opposite direction with those also. And then the intersection of line R, which is right here, with the plane, is going to be right at point K. That's where that line is shooting through that plane. Number 2 has to do with this three-dimensional solid, and we're trying to find the intersection of where plane BCF, so following those letters, BCF is going to be that bottom plane there, the bottom of the prism, or kind of like a ramp, I guess I'd call it. So it's the bottom of the ramp. But DEF is the back triangle, and it's in the back because it's using the dashed line. So DEF is the back triangle, BCF is the bottom, and so they're intersecting at that segment, that side EF there, or edge EF. The planes that are used to create CF are going to be this ramp here, the ramp going up, and then the bottom edge or the bottom of the triangular prism, just like BCF. So that's why I named BCF the same way, because it's that same plane, the one on the bottom. But then the ramp going up, you could use any 3 of the 4, actually you could use even G and H if you wanted to, but I'm using DAC just to keep it simple. But you could use DAC and F. You could also technically use G and H in there if you wanted to, but I just was focusing on the vertices. All right, now the skew line, this is where you might have some opportunity to cover some extra credit on the test if it's on there. But a skew line is a line that does not intersect, but it's also not on the same plane. So it's quite different than parallel. So if we take a look at CF, this line is shooting kind of front to back, but over here on the side. And I chose AB. AB is going to be like a pole, a vertical pole going up and down. But this AB is over here on this plane. CF is over here. And so they will never intersect simply because they're on different planes. And so that's what it means to be skew. They are lines that will never intersect, but are not on the same plane. Because parallel lines also don't intersect, but they're on the same plane. So like AD and CF are parallel. They will never intersect, but they're on that same plane, that same ramp there. So skew lines, again, and actually I'm going to give you some extra credit right now. You can email me with the definition of skew lines, which is that there are 2 lines that never intersect, but are not on the same plane. You email me with that definition. I'll get you some extra credit on the test. Okay. All right, moving on. This is my example of a line XY that's intersecting plane M at point K. That's my example there. Number 4, extending or finding the next 3 terms in the sequence and explaining your reasoning. So this was the Fibonacci, this is the Fibonacci numbers. So you're adding the previous 2, 1 plus 1 to 2, 1 plus 2 is 3, 2 plus 3 is 5, adding the previous 2 terms to get to the next. Okay, so let me zoom out here on those. So you can pause the video at this point if you need to take a look at all those answers. Okay, moving along to number 5, which is about conditional statements. We have a P, which is a hypothesis, a Q, which is the conclusion, premise, inverse, converse, and contrapositive. Now, these are not in the same order that we cover them in class. Not all geometry material and teachers teach it in the same order. So premise and converse, I would do first. Premise is if P, then Q. Converse was if Q, then P. So if the shape has 4 right angles, then it is a rectangle. If the shape is a rectangle, then it has 4 right angles. Now, this concept of being true or false, is something that you should be able to be thinking of a counter example for if you're going to say that it's false. And so a square would be something that has 4 right angles that is not a rectangle. However, if it does not have 4 right angles, then it can't be a rectangle for the converse and the inverse, actually. And contrapositive, remember, is if not Q, then not P. So those are just things to keep in mind with the conditional statements. Number 6 was technically a ratio or scale problem. So the scale factor, you guys want to make sure that you're picking sides that match. So the 35 and the 49 are on those corresponding sides, those matching sides. You just need to simplify that for the scale factor. So 35 over 49 simplifies to 5/7, so that's the scale factor. Then to find x, you could use the 35 over 49, that's what I did. You can see I have very large numbers. But I will tell you, you could also use the 5 and the 7 because those fractions are equal. Either way, you should get the same answer. Number 7 is a little bit of segment addition here. Clearly labeling, I did try to use the correct matching colors here. So KY is 5x minus 8, SK is 43, and then the whole thing is 7x plus 11. I highly recommend that you are labeling your diagrams. I understand color coding might not be an option, but then you can see that, okay, well, this piece and this piece together equals this whole, and that's exactly the algebraic equation. You just want to make sure then that you're answering the question, solve for SY. So SY is the whole thing. So that technical final answer is 60. All right, so let me zoom out here. If you need to take a quick moment to check your answers there, okay, you can pause the video. All right, number 8 is a little bit of an area and perimeter problem, but it does ask you to wind that down to some ratios just between these things. And I will say that we've talked about area ratios, but this is a little bit different because not between shape 1 and shape 2, not all 3 sides are changing. You can see the base of 20 is staying the same. So this is not like, okay, well, this shape is size 1 and this everything doubled or everything tripled or everything whatever. This is just one side stayed the same and the other 2 sides changed. So the ratio is going to be whatever the ratio is going to be. So we find the area, we find, oh, and I'll say some of you guys are getting the wrong formula for area of a triangle. It's 1/2 base times height. So that's the formula I'm using there for my areas. Perimeter is just adding all 3 sides together. And then the area ratios, guys, is just a fraction. Put them in fraction form and simplify. Okay, so the ratio of areas is 5:7, and the ratio for perimeters is 6:7. Number 9 on this one is going to be talking about parallel and perpendicular slope. Please remember that parallel slopes are the same and perpendicular slopes are opposite reciprocals. So you have to flip them and take the opposite of it. So since it's parallel to RS, all I had to do was find the slope of RS. So I used these 2 points here to find the slope, and that's the answer because they're the same. With perpendicular, I had to find the slope using Q and S, so 0, 5, and -3, -5. To find the slope is positive 10/3, but since it's perpendicular, I have to flip it and take the opposite of it, so it goes from positive to negative. You also can use the grid over here. This is just another way to do this math work. If you don't want to calculate, if you don't want to use this formula, then you can use rise over run over here. I don't prefer to do it that way. So either way, you still need to make the connection that the parallel lines would have the same slope. The perpendicular lines would be opposite reciprocals. All right, there's numbers 8 and 9. Number 10 is finding the midpoint. So that's just adding the 2 x values and dividing by 2, adding the 2 y values and dividing by 2. So I did get a decimal of 8.5, 4. Number 11 was really tricky for me even. So this one, I labeled everything according to what was given. So you just got to be really careful with how you are doing that. The right angle covers 2 angle spaces. So we have complementary angles here. Then this little sliver is just a value of x. This bigger sliver is a 2x plus 11, and these 2 together is 129. So this is what I ended up doing. If you look at my equation, the blue and the purple are the same. It's the whole angle. So I can get this whole angle by adding the blue and the purple together. I can also get this whole angle by adding the green and the red sections together. So that's what I ended up doing. I have no idea what this entire large angle is. I also could not figure out any other way to break it down where I would know because the green overlaps and the blue overlaps. So for me, I just figured, okay, well, the whole thing is blue plus purple. The whole thing is also green plus red, and they have to equal each other because they're measuring the same angles. So 129 plus x is going to equal the 2x plus 11 plus 90. So hopefully you guys can follow my colors there. And so I did that to find x. X is 28. Well, x is this little sliver over here. My ultimate goal, what I'm trying to figure out, is this middle angle in here. Well, if it's 90 degrees with these two put together, I know that this sliver is now 28. I just have to subtract them. So the actual finding of the angle measure here was not that tricky. It was the finding of x, what relationship we needed to use there. All right, number 12, angles 1 and 2 are technically adjacent because they are next to each other, but they are also complementary. So it says using all relationships, so I went ahead and selected 2. So since they are complementary, I'm adding them and setting them equal to 90, solving for x, but then the answers are supposed to be each individual angle, so I just plugged it back in. Okay. Number 13 was parallel lines cut by transversals. See everything here. So the purple relationship is where we had to start because those are the two that both have x's. So these are corresponding angles, and corresponding angles are congruent. So you set them equal to each other and you solve for x. Now that I know that x is 11, I know what this angle measure is, though I'm not actually bothering to find it right now. What you see here in green is me adding these two angles together because they're supplementary. They're a linear pair. So the green angles can be added to equal 180. So just instead of an x in 13x minus 19, I have 13 times 11. I just plugged it straight in because I didn't actually need to know what this angle measure is. I'm just plugging it in. So 13 times 11 minus 19 plus the 17y plus 5, those two angles together equal 180. I went down and I solved for y. So corresponding angles are congruent. Supplementary angles are linear pairs, add to equal 180. And then up top here in number 12, complementary angles are add to equal 90. So those are just some of these angle relationships here. All right, so number 14 isn't my favorite question, I think, because you just kind of have to assume that these are parallel or understand that these angle titles can apply to not being parallel lines. It's the relationships of being corresponding or supplementary or whatever. They only exist with parallel lines. So nothing here is parallel. They all look crooked, but the point is that like 8 and 10 don't have any relationship at all because they're on different, they're not even close. Like they don't have anything in common. This is a line B and C. This is a line A and D. Like they're not anything. But the other ones are technically found in these angle relationships here. So you can read through those. Number 15, we want the all trees have leaves. We're trying to find its contrapositive, which is if not Q, then not P. So if it's a tree, then it has leaves. It's just what I was thinking in my head. So if it does not have leaves, and this is the only one that does not have leaves. If it does not have leaves, then it's not a tree. So that's the contrapositive for all trees have leaves. Number 16, last one on this page. This is a proportion problem here. The tricky part is that it wants a total mixture of 45 cups. So you actually have to add the quarter cup of cake mixture and quarter cup of water to 1 cup of cake mix to end up with a 1 1/4 cup mixture. So a quarter cup of water ends up with 1 1/4 cup total. So how much water are we going to need with 45 cups total? So the W's and the T's here are just helping me make sure that I have a pattern, water over total mixture, water over total mixture. When I'm cross multiplying, the W is the only thing, like that's the variable that I'm trying to find. So 1.25 times W, 0.25 times 45 to get 11.25, divide to get 9 cups of water. So that's what I did there. Again, tricky part being needing the total with that proportion. Okay, there's 14 through 16. All right, I'm just going to keep this one zoomed out. The extending the pattern to the 11th sequence, you can see here, I just counted until I got to 11 and realized that it was going to be that image. Number 18 and 19 are interesting because they're using one formula to find a missing dimension and then asking for another formula. So given the perimeter, find the width, and then use it to find the area. Given the circumference, find the radius, and then use it to find the area. So both of those are multi-step problems. Number 20, again, I'll zoom in on this one, I guess. Number 20, you want to pay attention to my color coding. 16 degrees in this little sliver, 9x plus 17 in the bigger piece. The whole thing is 12x minus 6. So this was really just an angle addition problem. I can add the purple and the green, and it equals the blue. Okay. All right. At this point, I'll give you another little extra credit opportunity if you'd like to email me. I guess, let me tell you that I have a dog named Penny. If you want to email me my dog's name, I will give you extra credit on the test. Moving on. All right, 21 and 22 is using more angle relationships. 21 is linear. We have an overall supplementary relationship here with these three angles. But we do have a bisector, which means that these two angles are congruent. So notice I underlined in red that AE bisects angle CEF. So that's why my arcs are in red. And then the blue information tells me what those angle expressions are, but because of the bisector, those are equal. So that's what the equation is that I'm going to use to find x. Then when I have x, I can figure out what these angle measures are, which ends up being 51 and 51. So together they're 102. And that's important because this is a line. So if I take 180 and subtract 102, I can get the 78 degrees right there. Number 22, parallel lines. They are technically alternate exterior. All those acute angles are congruent, but their alternate exterior angles are congruent. So I can set them equal to each other and solve. And number 23, the only thing I don't like about number 23 is that we've been trying to use M a lot with our midpoint, but it says B is the midpoint. So we have an endpoint A and an endpoint C. You have an endpoint and B is the midpoint. So this is my X1, Y1. This is my XM, YM. These are my midpoints. So I'm still sticking with the M's there. A lot of you guys did okay with this on the last quiz. So this is the formula we're using to find an endpoint. Last one on this page, we are dealing with trying to decide what relationship line QR and ST have, if they're parallel, perpendicular, vertical, or none of the above. So if you find their slopes, one is 7/4, the other one is -4/7. So they are flipped and opposite of each other. So they are opposite reciprocals, which makes them perpendicular. Okay. All right, so that's the second to last page. All right, last page, 25 is an example of vertical angles. Vertical angles are congruent. So if it's 4x minus 1 down here, it's 4x minus 1 up here. That's important because we have complementary. We have 90 degrees right there. So the 39 plus the 4x minus 1 equals 90, and that's the equation I can use to find x. Number 26, comparing angles 7 and 11 was very tricky. I knocked out the first two options because they're not on, 7 and 11 are not on line J at all. So anything that has to do with J, I just knocked off. So those two are not options. M and N, because if we're going to use those two parallel lines, that they are consecutive interior. That is close, but we're trying to say that they're congruent. So I guess they could be. I bet in this one you could probably argue me that they are. You could probably say that I would accept answer C here, but only if we knew that they were 90 degrees, because the ultimate relationship between consecutive interior is supplementary, not congruency. So the only way that they could be supplementary and congruent is if they were right angles. And we don't have any information about angle measures, so it is possible. So I'll give that one to you as a possibility. Alternate exterior, the only thing that I could begin to say, see, they're not alternate. See, maybe I do like answer C. I think I do like answer C, because alternate exterior, they're not alternate because they're not on alternate sides of the transversal. We'd have to do a lot of imagining here. So I'm going to change this one. And I'm going to say that the answer is C, but they really would have to be 90 degrees. Okay, so we'll go with that one. All right, number 27, identifying a plane that is parallel to plane JKL. JKL is down at the bottom, so it's the bottom of the box. A parallel plane would not intersect it, so that's going to be the top of the box. So SRQ are the three letters that give me the top of the box. Okay, and I think that's it. Those are the last three problems. Again, make sure you guys are doing your check-in. Make sure if you have any questions, you're asking me. And I did give you a couple opportunities to email me with some extra credit points. So I'll see you when I see you.